Now again, coming back to the session. So the next question is, convert the following grammar into the Chomsky normal form. So basically, as per the definition of Chomsky normal form, so Chomsky normal form, when the given production is said to be Chomsky normal form, when it having the production is in the form one non-terminal symbol tends to two non-terminal symbol, or one non-terminal symbol tends to one terminal symbol, then it is called as a Chomsky normal form. So whatever the productions are given to you, that has to be converted into the Chomsky normal form. So for that there are some basic steps are there. So we will be see that steps in the solving the example. So these three productions are given to you. Some productions are given to you. The first production is what? S tends to small a capital A, or S tends to small a capital B, A tends to BAA, and so on. These are the production. Now if you take very first production, S tends to, if you take very first production, S tends to BA. So what we can do, if we substitute B by S1 in the equation number 1, then what will be happen? It will gives you S tends to S1A. So on the LHS one non-terminal symbol, and on the RHS two non-terminal symbol. So hence it is a CNF. Again if you take the second production, that is S tends to AB, that is S tends to AB, then what we can do, instead of this terminal symbol A, we can put here S2, so that it will give you S tends to S2B. Again it is a Chomsky normal form. Okay. Then talking about the next production, A tends to BAA, ASA. So you can see here A tends to BAA. As we know that B is replaced by S1, so we have put here S1 and AA will be remain as it is. So this is the thing. So it will gives you A tends to S1AA. But thing is what? It containing three non-terminal symbols on the right side, equation number 2, and which is not as per the definition of Chomsky normal form. So we have proceed ahead and we substitute here again S3 tends to S1A. So S3 tends to S3 is the new non-terminal symbols we have declared, and by putting that you can see here S3 tends to S1A, it will gives you here as a S3 and this A. Again it is a Chomsky normal form. And likewise you can see these are the some examples. Already S tends to A, that is a single non-terminal symbol tends to terminal symbol. That is the example of Chomsky normal form. So hence it is the one of the method for solving the example using the Chomsky normal form. And finally what you have to write? You have to write whatever the converted productions are there, you have to write over there. So that is the Chomsky normal form. Now one more interesting example is given to you, and that example has to be solved using some steps. So what are that steps? Initially we have to remove the null production, then we have to remove the unit production, and then we have to go for the Chomsky normal form. So that is the example we are going to discussing here. It is a very important question. That two questions are very important. It may be probably asked for the tomorrow's university examination. So if you see here null production, so which are the null productions are there? By the observation you can see this A, you can see here this A tends to null, that is the null production, means you can say A as a nullable variable. Again you have given D tends to, you can see here D tends to null, so that is again a nullable variable. So that has to be substituted amongst the non-terminal symbol, and we should try for minimization of the production. So if you substitute this null over here, then what will be happen? Let us take, you can see here in the above example nullable variables are A and D, as I mentioned earlier, because A tends to null is there and D tends to null is there. So now if you see the very first production, S tends to AACD. So very first production is what? S tends to AACD. we have to remove the nullable variables from this. So basically, yes is there, AACD I have taken. The first A I have removed with, I have replaced with A, if I replace it with null, it will gives you ACD. Again, I will be replace the last symbol D, it will gives me AAC. Again, I will be replace both the A's at the same time, it will gives me CD. Then I will be replace one A and D, it will gives me AC. And I will be replace AAD, all the three nullable variables, it will be gives me C. So that is the possibility after removing the nullable variable. Then in the second production, you can see, in the case of second production, A tends to A capital AB. So A tends to A capital AB, and after removing this A, we will be got here AB. Fine. So that is the thing. Then in the next case, C tends to ACA. So C tends to AC as it is. This A will be replaced. This A is as it is. This A is replaced with null. This small c will be remaining. And in the last case, D tends to something. You can see here D tends to ADA as it is. Then D tends to BDB as it is. Then we will be replace this D by null. This D by null. It will gives you AA and BB. So that is the result. That is the result. Whatever the things we have circled over here, that is the result after removing the or eliminating the null productions. Fine. Now we have to go for unit productions. So these are the things after unit production. So what is meant by unit production? The production is in the form one non-terminal symbol tends to one non-terminal symbol, then it is called as a unit production, and such a productions has to be removed from the given set of productions. So now we have to check such a types of productions. You can see S tends to C is the unit production. Okay. Also C tends to A is also unit production. So such a types of productions has to be removed. So that is called as a unit production removal. So in the case of unit production removal, yes, as I mentioned here, S tends to C can be removed. This S tends to C can be removed. Also we can delete the C tends to A. So these are the only two unit productions has to be removed. So if you see what to do, you can see here this AACD is as it is, ACD is as it is, AB is there, AC is there, CD is there, AC is there. This C has to remove. Fine. Then next one, in the last case also we have to remove this A. Okay. Now if you take the second production, A tends to, so whatever the production we have taken after removing, that is A tends to AAB AB. So instead of that AAB, instead of that A, we have replaced that A by capital XA. That is small a is replaced by non-terminal symbol XA, and small p is replaced by non-terminal symbol XB. So that is the first substitution. And again there was AB, so that is replaced by XA XB. Okay. Likewise we have performed this. XA is nothing but XA tends to A and XA tends to B, whatever the replacement we have did. So likewise in the case of D, again we have taken here XA D XA, XB D XB, then XA XA XB XB. Okay. And likewise again we have taken, for C we have taken XC tends to C. So after substituting all these things, okay, after substituting all these things, S tends to AT, that is one non-terminal symbol tends to two non-terminal symbol, T1 tends to two non-terminal symbol, T2 tends to two non-terminal symbol. Likewise you can say both having two non-terminal symbols on the right side, both having same non-terminal on the right side. And likewise we have performed all these things. One non-terminal symbol tends to terminal, one non-terminal tends to terminal, one non-terminal tends to terminal. So likewise all these things is nothing but, so that is the result. You can see here, that is the result for your Chomsky normal form. This one also, whatever is remaining in the below of page. So keep in mind all these things should be written in the examination. Go step by step. You have to practice whatever I have steps shown to you, and then you should be proceed ahead. Fine. Now next one is give the formal definition of PDA and draw the PDA for XC, XR, where X is a string and AB are set of input alphabet. Okay, so first of all, you should know what is the formal definition of PDA. So basically PDA, that is a push down automata, which is a 7 tuple, and we have to go for PDA of XC, XR, means we have to draw the PDA for palindrome. Okay, so as per the definition of push down automata is a 7 tuple. So what are that tuple? Q summation Q naught A delta. So the first 5 tuples as it is from the finite state automata. Then we are going to take here one stack symbol, and we are going to take the top of the stack symbol whenever the stack is empty. So these are the 7 tuples. So Q is what? Finite set of states. Summation is what? Input alphabet. Q naught is what? Initial state, and which is belongs to Q. A is the accepting state, and transition function delta is what? Q into summation union null into stack alphabet, which will be gives you Q into stack star, means stack string will be there. So stack is a stack alphabet. Z0 is the initial stack symbol whenever Z0 is where Z0 is belongs to stack. And keep in mind, whenever Z0 is present on the top of the stack, then you can say that that stack is empty. So that is the formal definition of PDA, keep in mind. And this is the schema, or this is the diagram for PDA. So you can see here is the input, here is the finite control, that is a PDA. It is going to accepting or rejecting the symbols. We are going to read the symbol from this position. Current state will be there, and by using this top of the stack symbol, we will be perform all this operation. Okay, so you can see here current state you have to take, that is a Q. Then you will be take the input symbol from this tape. Okay, then also you have to take the top of the stack symbol, and it will be gives you here new state with the some string will be push or pop in the given stack. So this diagram and the above description is very important, as I mentioned here below also. So what is meant by PDA? PDA is nothing but it is a finished version, or it is a little bit upgraded version of the push down automata in the, little bit upgraded version of the finite state automata. In the case of PDA, there is a stack. Okay, in the case of FA, there wasn't a stack. And push down automata which accept all type of except CFL, that is a context free language, or you can say type 2 is accepted by push down automata. Okay, fine. So acceptance by string by PDA. So basically when the string is accepted by PDA, there are two scenarios I would like to tell here. First one is what? Whenever the stack is empty. So I am going here little bit theoretically, you have to mention all these things. Whenever the stack is empty or all the symbols from the given tape is going to read, then in such a two cases the PDA is going to accept the string. Fine. Now the next question, this example will be discussed later on. Okay, don't worry, this example already I have in my notes. Yes, so this example of XC XR, so we'll be explain this later on. You can see a reference over there. Now see, if G is a grammar, they have given, if G is a grammar and it having two productions, S tends to capital S BS and S tends to A, then show that G is ambiguous. So already we know that what is meant by ambiguity. When the given grammar's production having more than one derivation tree, then it is called as a ambiguous grammar, and that trees are called as a ambiguous tree. Okay, you can see here. If a grammar have more than one derivation tree, then it is called as a ambiguous. In the above example, we consider string. Now, what we are going to considering? We are going to considering the string ABA. Not necessary every time you have to consider this ABA. Okay, so if I am considering ABA, then let us see here ABA. So these are the two derivation trees. You can see as we have given the production S tends to capital S B S. So that is the first production I have used. This is the terminal symbol, so don't worry about this. Again I have taken here production S tends to A as per the second production. Again from this S, using the first production I'll be go to S B S, and finally by using the second production A will be there. So if you go from left to right, the string will be A B A B A. So A B A B A will be read using this derivation tree. Again the using same production, that is S tends to S B S and S tends to A, I can go with the this diagram also. You can see here S tends to S B S, then on the left side S tends to S B S, then S tends to A, S tends to A, S tends to A. So these are also possibilities. So your observation should be very clear. What it shows, the first production tree or first derivation tree is totally different from second one. So it is a ambiguous grammar. It is a ambiguous grammar, or both trees are called as a ambiguous trees. Keep in mind this one also. Now whatever the earlier we have explained deterministic PDA with the example. So what is meant by deterministic PDA? So very important example of the deterministic PDA is the drawing of, keep in mind, drawing of deterministic PDA is what? Drawing of your palindrome with the marker. So that marker indicates that up to that marker we are going to perform the push operation. That marker will be used for reading one, and then we will be perform the push operation. So in the case of deterministic, if the question is asked, explain deterministic push down automata, then you have to write down that 7 tuples. Keep in mind whatever the Q summation Q naught A delta, then Z naught and stack symbol. So that has to mention. Then you have to draw the diagram. And in the case of deterministic, that is the example of deterministic. So this WCWR, it is the example of DPDA. You can see here DPDA. So this is the example of DPDA. WCWR. So W is the string, C is the marker, and WR is the reversal of the string towards the left side of that C. So that is the diagram you can see here. Already we have explained this in the class, but I am going to repeating here. So if you see here, these are the 6 possibilities, or these are the 6 movements at state Q0. Then while traveling from Q0 to Q1, 3 possible moves are there, or 3 transition. At Q1, 2 transitions are there, and from Q1 to Q2, 1 transition is there. So Q0 is the initial state, Q1 is the normal state, and Q2 is the accepting state. Now see this very important diagram. Okay. So what are the possibilities over here? So WCWR. So whenever you are looking for WCWR. So what are the possibilities with respect to this? It may be read C. It may be read ACA. It may be read BCB. It may be read ABCBA, and likewise. Means whenever the marker is present in the middle of string, you can see here this C is present over here, 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 and towards the left side and towards the right side they having the mirror image, that is ABBA. Fine. So basically the smallest string should be the C. Using this, because it is a 0, 1 star. Okay. So no issue about that 0, 1. So you can go with here as they have given 0, 1. So I'll be like to go with 1, 1. Okay. Here you should be take 0, 0. Fine. Here should be you take 1, 0 and 0, 1. Don't be confused with respect to alphabet. Okay. So these strings should be accepted. So the smallest string is C. So whenever you will be take the C, it will be at Q0. Yes, it will be at Q0. The symbol which has to read is C. Yes, the symbol which has to read is C. Fine. Just wait for a moment. Okay, so symbol which you want to read is C. So just wait for a moment. I have to take. Okay. So the very first symbol, that is a C Z0 means in this case C will be read, Z0 will be top of the stack symbol, and in the stack Z0 will be again keep as it is, and it will be change the state from Q0 to Q1. Now once you reach at Q1, it shows that there is nothing to read from the given tape, because C is the only symbol, so nothing to read. So you should be read the null top of the stack Z0, and it will be keep that Z0 as it is and going to the accepting state. So that is the first scenario, that is for C. Now whenever you are looking for another one, let us take here 10C01. Let us take the third one, 10C01. So it is going with, okay. Okay, so whenever you will be going for the 10C01, that 1 and 0, whatever 1 and 0, that has to be okay. So whenever okay, so that 10 has to be push, then C should be read, and 01 should be pop operation. So initially what will be happen? The symbol 1, so you can see here, we will be go through this. Okay, fine, that's great. Okay, so what will be happen? 1Z0 means what? 1 will be read from the given input symbol, Z0 will be top of the stack symbol, and on the stack that 1 will be write, or 1 will be push over there. So now on the top of the stack 1 will be there, and 0 will be the reading symbol. So 0 1 0 1. So right now the position of stack will be top of the stack 0, then 1, and then Z0 will be there. Now we will be reached to the C. We will be reached to this C. So once you reach to the C, what it indicates? Once it reach to the C, what is the top of the stack symbol? 0. So C0, C0, okay, so C0, this one. What I would like to say here, so you will be go for this second production. C, C00 means what? It will be read C, yes, then top of the stack symbol is 0, okay, and it will be keep that 0 as it is on top of the stack, and only changes what? It will be change the position from this Q0 to Q1. It will be change the position from Q0 to Q1. It will be change the position from Q0 to Q1. Now once it reach to the Q1, that is it change the state, what it has to do? So now 0 and 1 are present in the top of the stack, means 0 at the top, then 1 is there, then Z0 is there, okay, and there is nothing to read. So there is a reading is what? 0 and 1 is remaining over the that particular tape. So that 0 0 0 0 will be, so this 0 from that input symbol and this 0 from top of the stack, that will be pushed down and null will be there. Again 1 will be present for reading, 1 will be at top of the stack. Again what will be happen? 1 1 null will be there. Now what will be the position? All the symbols get read, so null will be present on the given input string, Z0 will be the top of the stack. So whenever such a types of situation will become, just go from Q1 to the Q2, and hence it will be accepted. So just wait for a moment, I have missed that particular setting. I have to highlight that one. Highlight it again. Okay. So if you see here, these are the 12 possible moves. First move is what? Current state is Q0, input symbol is 0, top of the stack is Z0, it will be remain at Q0, and this 0 will be pushed in the stack, and the symbols in the stack will be 0, Z0. Then in the second case, Q0 will be there, second possibility, 1 will be the input symbol, Z0 will be top of the stack, it will gives you Q0, 1, Z0. Then next one is Q0 is there, that is the current state, input symbol is 0, may possible that previously we have performed some operation, that is pushing up 0 in the stack, so that's why top of the stack is 0, it will give you Q0, 0, 0. Likewise Q0 is there, 0 is there, 1, 0, 1 will be there. So these are the productions you have to keep in mind, very simple production. First 6 productions are for pushing, keep in mind, 6 productions are for pushing. Then 7th, 8th and 9th for changing the position from Q0 to Q1. Then this 10th and 11th. This 10th and 11th, which is for pop operation. We are going to perform here pop operation. You can see here pop operation. And the last one, 12th one, which is the operation at the specific accepting state. Okay. So thank you so much for your patient listening. We will be continue in the next lecture. Just wait for a moment.